And welcome back to Pharma-info. It's Shubhashish. Now today's topic is synthesis of Dibucaine, right? So Dibucaine, as we know that Dibucaine falls under the category of local anesthetics, right? Local anesthetics. Local anesthetics, right? And basically it belongs to the chemical category of amide local anesthetics, right? Okay. How it acts and all, what are the side effects and all, we are least concerned at this very moment. Why? Because our concern is of synthesis, right? Now, so local anesthetics get topically used and basically used for the purpose of say itching due to hemorrhoids and all. This is the drug of choice. Okay, this is the local anesthetic of choice. Once a particular subject is having the hemorrhoids and all, probably there is an itching, right? Frequently he or she feels some sorts of itching at that particular area, right? That time it is the local anesthetic of choice, which can at least give some sorts of relief from the itching and all, right? So now let's move on to the chemistry, the chemical features of Dibucaine, how it looks and all, and from there only we'll just find the ways, right, by which we can make Dibucaine and all, right? Okay, chalo. So what the name suggests? So Dibucaine, can we find some clue from the name itself? Yes, name and chemical category. So these two are the chemical category, right? Just now we talked about the chemical category. It belongs to the chemical family of amides, right? So therefore, this particular fragment should be there, right? Should be there. What is the other thing? Let us just focus on the name, right? What the name suggests? So within the name, Bu is there. That means a butyl, that means C4H9 unit should be there, right? C4H9 unit, right? And say here di means two similar substituents, okay, should be there, right? Should be there. Now, so let us move on. Let's move on, right? So with all this information, let us just try to build the structure of Dibucaine, right? So Dibucaine possesses the heterocycle, that is quinoline. So it is the quinoline that is there or in the structure of Dibucaine, right? So this is quinoline, right? And 1, 2, 3, 4. At fourth position we have the amide, that is CONH. Chalo. So CONH, as we got the CONH, therefore we'll just rub it off CONH. We'll just put CONH here. CONH followed by what? What we observe in other amide or anylides local anesthetics in case of lidocaine and all. In case of we have something like your lidocaine, then your mepivacaine, bupivacaine. So all belong to this amide category, right? CONH followed by a link, that is linker, that is CH to CH2. After that N, and it is the N that should be tertiary in nature. Therefore, it should possess two substituents, as we found that as we already found that di, that means two similar substituents, they are found to be C2H5 and C2H5. So this is the feature which you can find in case of procaine, the ester local anesthetics like procaine, then procainamide. So all these are having this kind of feature. That means diethyl aminoethyl. This is there. In addition to this, okay, it also have but, that means butyl. So we'll just put here C4H9, right? And the butyl is not in the form of butyl, rather in the form of butoxy. So therefore OC4H9. So this is found to be the structure of what? Dibucaine. So this is the thing that we got. This is found to be the structure of Dibucaine. Now let us move ahead, move on to the next thing, that is IUPAC naming and all. So what should be the IUPAC name? IUPAC name is, it is basically it contains what? Quinoline. So quinoline is found to be the template for this particular compound, right? So this is the template, quinoline, and quinoline is nothing but quinoline possesses at its fourth position amide, carboxamide. So the parent is here nothing but quinoline carboxamide or quinoline 4-carboxamide is found to be the parent here, right? Now let us see what are the substituents that are there with this particular structure. The substituents are diethyl aminoethyl, okay, and it is the nitrogen, that means amidic nitrogen, that is holding what? This diethyl aminoethyl, right? One thing. The other substituent is butoxy, placed at second position. So likewise, if we just proceed with the IUPAC name of this particular Dibucaine. So what should be written? First we should start with this things like n. So n is holding what? 1, 2. That means n is holding 2. Then 2 of what? 2 of this ethyl. 2 of this ethyl. So this is diethyl amino. Sorry. Just write it off. Diethyl amino. We should close the bracket, and then 2 is of what? 2 of ethyl, right? So likewise ethyl. Close the bracket. So we are done with this particular substituents, right? So we are done with this particular substituents. Now, what next actually? Okay. So the next is this one, that is 2-butoxy. So 2-butoxy, and then finally quinoline 4, because 1, 2, 3 and 4 carboxamide. So this is how the IUPAC name we can generate, right? So this is about the IUPAC name. So what we observe here, so observe, you can initiate the process, you can just make it in an alphabetical order like 2-butoxy, and then we'll move on to the the ethyl and all, right? So you can start the process with 2-butoxy and then move, or else you can start the process with the first one, that is carboxamide, that is N, the holding the largest the largest substituent, right? That is your N. Then like this, okay. Once we done with this N, that is 2-diethyl amino ethyl, and then after that we have another substituent like 2-butoxy, and then quinoline 4 carboxamide. So this is how the IUPAC name stands, right? Okay. Now let's move on to the making and all, right? How this can be made and all, right? Okay. So we'll definitely follow the established process, and the process says that in that process you can find, or you'll see that ring expansion will take place, right? Ring expansion. That means probably we should not start the process with 6-6 system. We should not start the process. As I said, ring expansion, we have only a single ring, that is the quinoline, right? So that means we should not initiate the process with 6-6 system. Instead, we'll just make it 6-5 system, right? Now let us see that what is there with us which is having 6-5 system, right? So 6-5 system can be of like this, and to that 6-5 system, this is found to be the additional thing that should be there with this 6-5 system, and this is called isatine. The name of this particular system is called isatine, right? This particular ring system, okay, which is incorporated or which is used in making anti-cancer drugs. Okay, this is a very good scaffold moiety, right? Okay, and see, it is clearly visible that this is nothing but an indole derivative, right? So isatine, and next to this isatine, we have to react this isatine with acetic anhydride, because initially we need to do acetylation. So step 1 involves acetylation, and that too with the help of acetic anhydride, right? So what this acetic anhydride will do, definitely it will furnish what? It will furnish the acetyl moiety to the hydrogen, or to the nitrogen of this NH, right? The hydrogen got replaced and the CaOCH3 will get inserted rather, right? Chalo. So now once this particular reaction, okay, will take place, okay, then after that, as a result of this particular reaction, we'll get what? We'll get a product that is like this. So now we got what? The first intermediate we got, and that is nothing but N-acetyl isatine. So this is found to be the first intermediate, that is N-acetyl isatine. Now what next actually? Let us see what next. The next is a rearrangement has to be taken place, and through that rearrangement definitely the ring expansion will take place. It is the rearrangement that should take place in presence of a base, strong base, that is nothing but sodium hydroxide, right? So we have got the first intermediate. To this first intermediate, we'll just try to react this with sodium hydroxide, and the kind of reaction that the kind of reaction mechanism that is happening here is found to be the rearrangement, right? So it is the rearrangement that eventually leads to the production of what? That eventually leads to the production of a particular compound in which you can find the template has become from 6,5 to 6,6. How this is possible? How is it possible? So now when sodium hydroxide act on this, what we can expect? We can expect a particular compound in which the feature is found to be like this. So all we got is like this kind of, or rather I should say this is found to be something like this. So this is the thing that we got. That means 2-hydroxyquinoline carboxylic acid we are approaching to the next is we need to make this and this a halogenated derivative, right? So how is it possible? Just treat this with PCl3, phosphorus trichloride. What this phosphorus trichloride will do? This chloride, this will liberate chlorine, right? And one chlorine will get attached here, just carboxylic, now has been converted to COCl. And what about this? This has got converted to Cl, right? So we got something like this. This is called what? 2-chloroquinoline carbonyl chloride, right? It's a derivative, carboxylic acid derivative. Now what next? Once we get this kind of thing, what is left in the process? Okay, we have to make this area into butoxy like OC4H9, and this area we need to condense this with what? With C2H5 diethyl, then here it is CH2, then what next? NH2. This is the thing, right? Okay. So ethylene diamine actually. So NN diethyl ethylene diamine. Why? Because here CONH, we have to make this area CONH. And that is why this H, one of the H of this terminal amino will get expelled. Okay, this has to expel. Okay, this has to expel, and in the process of in the process of removal, what this will definitely add with this chloro, right, and just leave from the system in the form of HCl, right? HCl. So how this will take place? So this is the reagent that we'll look after, right? This is the reagent with which the condensation will take place, with which the amidation will take place, right? Chalo. Now let's move on to this, right? So initially what we'll do, we'll just try to react this carbonyl chloride with HNH, CH2, then N, which is tertiary, that is C2H5. NN diethyl ethylene diamine, right? So now when these two will react, what will happen? Definitely HCl will go off, right? So this HCl will go off, right? Leaving behind what? Leaving behind an amide of this sort, right? So this kind of amide will emerge out of the process, right? Chalo. Now what next? What we are left with? What we are left with? Alkoxylation at the second position. So how this can be accomplished? Say we have with us like sodium butoxide, right? Because we need to add what? Butoxy, not butyl, right? So that is why we need to react this with this in presence of sodium butoxide, NaOC4H9. So what will happen? What can be expected? Na will definitely react with this chloro, right? So what will happen? NaCl will go off, right? Leaving behind what? And the connection ultimately has been made in between this carbon and the butoxy, and thus we got what? Thus we got the structure of the compound, that is Dibucaine, as a local anesthetic. So this is how the reaction, the reaction takes place, right? Now, so this is all about the making of this butoxide. Okay. Now, as a whole, what we observe. Now, so now if we just try to brush it up, right? So it looks like this, right? So we have started our process with isotene. It reacts with acetic anhydride. So what happened here? The acetylation took place where? At the isotonic nitrogen, right? And then with this particular intermediate, we just try to react this intermediate in presence of sodium hydroxide. So rearrangement took place, and it is the rearrangement reaction, okay, rearrangement, that eventually leads to the production of what? A carboxylic acid. And here we found what? This is found to be 6,5 system. It has got transformed into 6,6 system that we are after actually. So we got here carboxylic, we got here hydroxyl. This is 2-hydroxyquinoline carboxylic acid. This can also be called as synconic acid. And after that, we just try to react this intermediate with PCl3, right? So what we observe here, that the PCl3, while being treated with this particular intermediate, so both the areas like second and fourth, right, both will get transformed into a halogenated one. So this got converted to oil halide, and this is about chloro, right? So once we got this intermediate, we just reacted it with diethyl amino, or rather NN-diethyl ethylene diamine, right? And we got what? The condensation took place, and we got what? The carboxamide, that is 2-diethyl aminoethyl, then 2-chloroquinoline carboxamide, right? So now one step, we are left with another step, that is butoxylation at this area. So this butoxylation has been done in presence of sodium butoxide. Thus we get the structure of Dibucaine, right? So this is how the reaction took place. Right? Hope you understood the fact and file, okay, which is there in this particular synthesis. Now, so with that, I'm just concluding to this session, right? Stay tuned for the next video to come. Thank you.